Hello everyone. Today I'm gonna talk about full reactive apps with asynchronous flow and StateFlow to sync with the UI. First of all, let me introduce myself. I am Raul Hernandez Lopez. I work as a software engineer at Twitter here in the London office, nowadays in the London time zone. If you want to follow me, that's my handle. You will see that in the presentation. And also you want to see the code snippets of the presentation from today. This is my GitHub and also my guest account. So you can see later on here the code snippets. But let's go to the agenda. Today, we'll start with a little use case about actually how everything makes sense into this presentation. I will explain that, then I will introduce you the migration strategy that I took and the things that I think are interesting to take into account when we do a kind of big migration from RxJava to the new Kotlin Flows and routines in general. Then the basics that for me are really important because it's for me something to master later on what we're gonna do and also to precisely understand what we are doing and why. And then the later and longest section of all of them is the implementation one. So bear with me on that. And finally, the lessons learned along the way. And if we have any more next steps, we'll see them as well. So let's go to that. First of all, the use case. And the use case is something like this, something quite simple. It's just a use case simple enough and complex enough to see all those different edge cases that we can see. Is, as you can see, a user typing something now failing miserably like I am doing right here. I'm trying to do tweets with flow right now. And finally, when I do it right, you can see also a view detail of this particular tweet, but you have more than one result. You will see that later on. And that's basically it. Is a search kind of engine that I built from the ground up. And this is actually something I built like 3 years ago, actually a bit more nowadays. And I try to migrate that from a very old kind of stack technologies. And you will see that in a moment, which kind of things I have. So let's see what migration strategy I followed at the time. First of all, because this is very legacy, I have to do a lot of refactoring. And by that, you will see a few things that, in my opinion, were pain points that I want you to mitigate if you could. For instance, to follow in some steps that I think are relevant and can be helpful for you. Let's say we're gonna, first of all, analyze the architecture we had at the time. In my opinion, you don't need to change from scratch your architecture. You have something that is working for you, you can keep going. So that's why I follow this approach also to me here. And yeah, first of all, I changed the data layer, which is composed by a repository. And this repository from the data layer is also composed by a network and a database data source. All, as you can see here, built from the run-up in Java. That was connected with the business layer, the use case precisely, or an interactor, however you want to call it. This was actually requesting information to the repo, and the use case doesn't really care where it is coming from, this network or database, but the results is coming back from the use case when this is executed. And actually, the presenter is the one executing the use case. So the model view presenter coming from the presenter is combined with clean architecture, which is coming from the use case to the repo and the data sources. All, as you can see here, again, built from the ground up with Java. So the presenter actually is called from the view because, as you can imagine, the user is typing in this use case that I told you a moment ago. And then by typing, the views are reacting to that. And I use something called view delegate, which is something as simple as delegating things from the view because we don't want to have the view with any responsibilities. So the view delegate gonna do this kind of mechanism for us, starting the presenter, executing the use case, making the request to the repo, and getting those results back. The results are actually coming by means of callbacks from the use case to the presenter to the view. And that's why I put views callbacks on that. The view delegate then going to be a kind of a hot mechanism, a kind of hot observable, starting to react. And then by means of the view listener that we have in the view, we're going to react and start the presenter. So this is basically why this is working that way, from the typing to the different things and mechanisms that I have in place right here. But now, let's see what's the check. We have to check actually the backwards compatibility with the things we had at the time. As I mentioned, I use RxJava for everything that I needed and for creating this kind of reactive approach and mechanism. For instance, right now we need to make this coexist between the old and the new at the time being, because we will not do a big migration to migrate to coroutines and Kotlin flows. This needs to coexist and then try to do it step by step. And by that, I mean, we need to analyze the pinpoints and the connections that we have along the way. Once we do that, here we can see that the RxJava is basically in the whole clean architecture side, coming from the use case to the repo and the refinement mechanisms over there. And also I have a hot observable coming from the view delegate, which is triggering this mechanism and the different queries. And by means of those queries, we are starting to create this reactive approach from the center. It's nothing really surprising, I guess, for you. This is MVP with clean architecture, as we all know. So let's go for it. Right now, I'm going to start the migration. So I'll do this from the deepest layer. That's my approach. You could do that from another way. You could do that starting from the views, but that's something that I think is interesting as well. Because if we do that from the deepest layers, those possibly are more independent, more isolated. So you could start from them safely and then migrating upwards in this case. So I started with the database. I changed that to start using Kotlin, not Java anymore, but still returning this value with single in this case, or observable. That is up to you really in that case. Same here, I started to introduce those and then returning those values who are singles. And because my repo is expecting that, I will have to do that. Then again, the repository is returning an observable. It is going to be implemented in Kotlin. Then later on, I will introduce everything returning values with suspend functions or maybe flows. And then the repository will expose that returning again an observable because the use case is not yet prepared for that. And then when this is prepared and I am passing a flow, then the use case should be able to recognize it when it's available. So in this case, we'll use flows that are going to be collected here, and then we can just process our results back. Still, we can use the callbacks for it, why not? Then we'll introduce the case for the view delegate. We want to also replace this Java and RxJava with channels and flows in this case. That's one of the possibilities we could use. And if we do that, possibly we want to also remove the callbacks if we have some time. Is that possible to do that? I would say a good approach could be to use StateFlow for it. So just wrapping our results in a StateFlow, we could collect them from the view. But you see right here, still I'm using Java for the views. So that means that StateFlow can be passed across all of them. That's not really a problem. But we have to take into account that we need something else, because if we need to collect something in Java, that's not possible with coroutines. You need something in Kotlin to collect that. And the reason for that is because we need a context and coroutine context. And this should be into actually a Kotlin file. So that's why I created something called a StateFlow handler. You can call it as whatever you want. Or if you don't even have a view with Java, you can directly do it in the view. That's really up to you and how you decide to do that. So by having that, the few benefits I find are, for instance, reusing existing components, because we don't need to migrate all in once. We can just get the existing components, existing architecture, making sure that with a black box kind of mechanism, we have some inputs and we are returning those inputs as some expected outputs. And those outputs are going to be something that the next layer can rely on. And that goes directly to the next point of benefits, that is the layers collaboration, because you can expect certainly what you're going to have from the next layer. So if I have this contract returning an observable, I will expect that unless I have migrated to the next stage, which is I am prepared to use flows. So you do that step by step, you're going to have it ready. And that's my tip for doing that. So let's go to the basics now. That's going to be a quick section just for you to understand a few basics that I use across my implementation. So let's see what we have here. First of all, what is an open stream for me? An open stream is something as simple as, let's say I am right now doing welcome greetings to you. And the other person in the other side, Christina, received that. And she tells me that she is right now practicing or learning some advanced maths. And we could stop right now the communication. And if we do that, that means this is a closed stream because it's one communication that has stopped. This analogy can be similar to a network request. When you request something, you can just stop it, and if you need it again, you will raise a new request to the network. But if we follow this communication, this can be an example of a messaging application, a real-time communication in a chat, or a communication face-to-face. This is actually an open stream. If the conversation keeps going and you can expect a new message to come in a moment you don't know when, that's actually an open stream. But we also have another example where we don't really need open streams, right? Because if we need a network request, then we'll use something like singles as a return type. That means that for coroutines, we use a suspend function with an object that is returned right here. But if we want something with a nullable object, we'll use maybe in RxJava or suspend function with a nullable object as a return type. And the other type we are missing probably is the completable in RxJava, which is mainly a suspend function with a value being returned. That's unit. We can use void at Java because it works differently in Kotlin, if you remember. So that's the unit right there. So now that we know that, let's see the threading. For the threading in RxJava, we use schedulers. Schedulers have different types, but we'll see them later. I don't want to mention them right now. The comparison to that with coroutines is using dispatchers. This is the things we're going to use for the different thread pools that are equivalent from the schedulers in RxJava. But now probably the most important bit for me of the basics is the lifecycle. We use actually disposables for RxJava. And the disposable is going to be responsible of having the life cycle right there, and you can dispose them when you don't need them anymore. If you need the same for coroutines, you'd use something like scopes. Scopes are similar to the disposables, but actually are bigger than them. They have superpowers who's not really belong to disposables. For instance, startup concurrency. Startup concurrency is super cool because you have a few benefits that you couldn't have with simple disposables. For instance, recursive cleanup. What does mean something like that? That means that you have this scope over a few processes, and those processes are running right now, and you cancel this scope. You could, let's say, cancel all of them, and you wouldn't need to do it one by one. That's very cool because you don't have to take care about any of them separately as you will do with disposables. The solution in disposables will be to use composite disposable, or using something else if it's from a different layer, because you have different layers, you have to do it separately in the different layers. But then if we use scopes, we can have for free recursive cleanup and avoiding with that memory leaks. That's super interesting to use. Then we have another use case that is different and going to be very useful. Is the one I use for my sample app. And it's basically getting a scope plus a supervisor job. If you're familiar with this kind of approach, it's basically avoiding other children cancellation. And by that, I mean, if we have this scope plus supervised job and the process one just get an exception thrown because let's say we have a problem in the network and you don't want to cancel process 2 and 3 because are very interesting to keep going, then by having this scope plus supervisor job, you won't cancel process 2 and 3. They will keep going. They will keep working. And yeah, that's basically it. For the implementation, we'll see what we have now. First of all, we're going to need to use some Gradle dependencies, of course. This is quite the basics. So you'll use coroutines core and Kotlin coroutines Android for the dispatch of Android. And of course, the Kotlin standard library, which is for Kotlin. I use here the 140, which is stable, makes stable actually StateFlow and StateFlow. Obviously, there are newer ones, but this is quite stable, so I really liked it. And now let's talk about the migration in the data sources. First of all, the network and the database. So initially, I'm gonna make this changing those singles to use spam functions and returning those spam functions from that, and finally returning what is expecting the repo to have. So let's see. In the network data source implementation, I have the Twitter API, which is basically a retrofit with OKCTP client. Then something called connection handler. This connection handler is just to check if I have any connection, if I need to check it. And then to process the different responses and requests, I have this requests IO handler. That's all I have into my data source. This is going to be a singleton because I don't want to reproduce it every time that I need it. And then for the method I use right here is the search for the Twitter API. So I use a token because this is an authenticating search for the Twitter API. And then I pass the query that is coming from the view. Then I filter that if I don't have any problems. Then I map things to get the tweets that I need from my DB. And then this is going to be passed to become a single. And then I will return the single. This is, as you can see, still Java. But let's see, if we go to calling with suspend functions, we'll simply change the return type. We'll put the suspend thing right there, and then we'll pass the query and the token again. As a return type, I use either from the arrow library, but this is very similar to using calling result. So something as simple as that. We'll see that in a moment, but yeah, I search this thing, I get a response, I check if the response is successful, and then I get the tweets, and then in my either right side, I pass the tweets if this is successful, but if I have any problem, I just pass in the left side, which is the wrong side of the either operator. And I pass this back, and because we need a single, I use this library called index coroutines rx2. And with this, I will pass an Rx single, which is basically what I need to have there, a single. I pass that to my next layer, who gonna be the repo. And then, because the database is gonna be passing the result back, I will pass this as a single as well. So this, as you can see, is just having an input for the different tweet IDs in a descending order coming from the table from my tweets. Now, I passed the repository and what I call actually the naive approach. You will see in a moment what I call it the naive approach, but it's basically because I came from the RxJava world, I want to learn how to do the things, but I probably made some mistakes because I was trying to do this approach, which is for me the RxJava approach. And this is something as simple as starting with Kotlin, Flow, and RxJava. So you see, I already migrated, as you can see right there, the data sources, passing the Kotlin things with the different suspend functions. And then in the repo, let's go to there. I have inside that the network data source, which is basically the entity that you saw a moment ago. And then I have the different tables, the tweet, the token, the query, the combination of the token with the query, and then the different mappers to pass different entities from the network to the data source. And something called data task threading. The task threading is something that's gonna be a bit more complete, and I will explain that later. So this is basically what is composed into my repository. Again, this is a singleton. So the mechanism I have here is searching for the tweets. So let's start from the network data source. I search for the query, passing the token, I can authenticate it. I subscribe to the IO token, sorry, not the IO token, the IO thread pool, because it's coming from the input output. And then I will serve this into the computation because probably I will need to do some operations in my use case. Then I'll map the results to get those back, and then I'll do on next. I'll pass those tweets and I will start the updating from the database. So I will delete the previous tweets and I will insert the new tweets. I'll insert the query and I insert the different tweet IDs in my table that is referencing both the query with the IDs. This is a way to do an update in the database, but you could use update, but that's the way I did that. So I use, as you can see here, do on next, which is basically an observable. And then I'll do flat map of that operation, retrieving those different things from the query, and then flat mapping again for getting those tweets IDs and then getting those results from the database. And then I will return this back with an observable. Then if I want to do the same with flows, I'll pass a flow right here. As you can see here, this is super similar. So I use map. I'll use on each instead of do on next. So something equivalent. I don't have to tell you again those steps because you know them already. Then I used flatmap concat instead of flatmap, and again another flatmap concat right there. And I return back those flows right here. So we got it. We have this naive approach. It works all fine. In the database, and I changed the return type to return a flow of list of tweets. So far, so good. Everything works as expected. And now, because we want to also do something similar to subscribe on in RxJava, I'll use flow1, which is operator in charge of making this work in the input-output threading. That means for the dispatchers in coroutines, because flows and coroutines work, in this case, upstream. I use flow1 right there. So this is going to be affecting all the things, all the operators that are at the top of the flow1. So this is something to take into account. And as I promised, that threading implementation is having a few things right there. I use different schedulers for Java, for the computation thread, for the input-output, and for the main thread of Android. And I expose these by methods like UI, IO, and computation. Those are going to be like that because I want to mock them later to change them for unit tests. That's why I use those methods. And then I can do the same for the different dispatches that I need for coroutines. But right now, if we use something like that, the main difference is that we're going to use 6 resources in memory. So can we actually reuse those schedulers in order to use less resources in memory? That's absolutely possible. So what I did actually is to use, again, that library that I mentioned a moment ago. And by using the as coroutine dispatcher, I will convert those schedulers to use coroutine dispatchers instead. Then by having those, I can return the different types that I expected to have with the coroutine dispatchers, and then those can be used for my different flows and coroutines in general. Cool, so far so good. Using the same library, Colonix coroutines Rx2, we could return an observable right here. So I can make sure that the return type from this flow can become an observable by using as observable. And this is going to be returned as the return type because again, we need to, we're going to expect that from the interactor or the use case. And now let's go to what I call the pro approach, the suspend approach, when we know a little bit more and we don't rely in our previous knowledge of RxJava. So now we have everything almost transformed. We're going to have the flow and different things. So let's go from this side. And let's see the search tweets. Search tweets is passing the query. I'm going to pass back a list of tweets. This is a suspend function. And again, this code is super easy to read. So we are getting the access token, we are getting the token, we are making a search to the network. I am passing the header that you know from the arrow library. I am mapping the results to become tweets. And then I am doing the update, sequential code, as you can see here, very simple and easy to understand. I am making the update and I am passing those things from the query and returning back those things at the Twitch IDs. But wait, I'm trying to do here something a bit weird because I have a suspend function, which is one shot operation. You remember that I explained earlier the difference between open streams and not open streams, in this case, closed streams. So this is a closed stream because we are returning a suspend function with a list of tweets. But I am trying to do here something like returning a flow inside that. Is that even possible? No, it's not really possible. So try to avoid that or you will have a compilation failure. It's something I try, just to try things. I'll learn from my mistakes, why not? So something that will work actually is to return as a spam function from the inside in the retrieve all tweets from Twitter IDs. And this is going to be expected. You can return this list of tweets and it will work. So basically having something like that, retrieve all tweets from Twitter IDs, will return as a spam function or list of tweets. This will work because the room library is compatible also with spam functions. And this is going to do the work for us. But now we have a few more cases. For instance, if we want to do in the repository something like emitting all values in a flow, by the way, this flow builder is something that probably we're gonna use very frequently when using Flow, because inside you can emit different set of things. In this case, I use emit all, because if I return a flow from the retrieve all tweets from tweets ID flow, what is interesting here is the fact that by using this kind of thing, you want to have, let's say, a poll by having different network requests every certain time, let's say every 30 seconds, and you are wondering to have your UI refresh every 30 seconds, this emit all will have the stream open for you to have this communication with the UI, and then you can refresh anytime because you are having this open stream. This flow I'm going to be with the IO dispatcher, but that's all. That's one of the cases. Another case is to have, let's say, one emission, one emit, returning a suspend function right here because it's one shot operation. This is actually possible. We have the flow, we are emitting one value, nothing else, but does it make sense? I will say if you want to do something like this, you can just return a suspend function, returning a list of tweets, and you don't need a flow right here, which is the first case I mentioned earlier. But if we want to have something like different emissions inside, this is actually an open stream, and this works. So I'm gonna do the flow builder here. I'm gonna emit first the dirty values of the database. So I'm gonna return those. And then after that, when I have everything refreshed from the next network request that I did, I can emit those values from the DB that are again updated. So I have two emissions, dirty values, new values, and this works because it's an open stream. So that is perfectly valid case. So we'll return again an observable with this because we still are expecting that from the interactor side, the use case. Let's do this refactoring for the use case now. So we want to have this ready to use flows. So we see what we have to do right here. First of all, this will be in our time scope because the configuration changes that we have on Android. I'll pass inside the tweet repository and then the task threading. This use case is going to have a contract with search callback, and this use case with this contract is basically something like this. I have a generic parameter that is actually the callback, and I will pass an execute method with a parameter that is a query. That's a string. And then I will cancel this later for dispose, in this case for RxJava, or cancel in the scope if I need it. So something like that. The use case is going to have the execute with the query and the callback. This is again in Java. I initialize the callback. I show the loader. That's the pop-up to the user. Then I will search for the query. I will subscribe to that, and I will pass the successful results with a callback or by means of on error, the error handling that I have right there. Then we obviously need to subscribe to the computation thread that is coming from the repo, and we'll observe that into the UI because we need to show the results into the views. And then if we need to do some mapping for the computation, we'll use the map functionality right there. And then if we change this to Kotlin, we'll just change this to have the query and the callback. That's equivalent. We initialize the callback. We'll show the loader. Then the different bit is using the scopes. That is something we know we need to use for coroutines. Actually, I create this coroutine scope that is composed by the UI dispatcher and the supervisor job that we all know from the basics. And then this scope.launch gonna be ready to launch the coroutine and then searching the tweet with the query, mapping the results, that's equivalent to the previous thing, and then flow on with the computation dispatcher. Again, if you need to do this map with the computation, remember that in Flow, you need to use flow on with upstream. That means everything that is in the top of flow on gonna be with this particular dispatcher. That means computation. Then I'll capture the different errors, and then I could collect the different results. In this case, if I have tweets that are valid, then perfect, we have it. So this is actually a shortcut that for me works very well because the launch that you have at the beginning is the same that using launch in later on. If we use instead on each, so the on each gonna be the collect and the launch is gonna be the launch. So you could use after the flow on each, you could use the catch, you can use launch in with the same scope that we know already. That should be all. And then If we want to cancel this with the structure concurrency getting in place, we use in the cancel the scope.cancel, that's all. Obviously, we'll make sure that the callback is null just to avoid memory leaks. And then if we need to do the same with RxJava, we'll need the subscribe on and observe on, subscribe on in the computation, observe on in the UI, and then the cancellation. We'll cancel the disposable, we check if it's not disposed, we'll nullify that, again the callback nullified, so it's very similar to the previous approach. Then we'll return actually a flow. We don't need any more of the observable, so we can remove this from the repo. You remember we were returning the observable, now we don't need it anymore. That's fine. We made that possible, cool. And now let's see the view delegate design. For the view delegate, we want to have this with channels as flows in this case. These channels as flows are gonna start with the view delegate. So the source tweet presenter, and inside that, I will have a public subject in RxJava. That can be a behavior subject. You want to have the later result immediate all the time. Now, inside there, I will use the search view. Search view is the native component of Android. You could use a text, edit text, for instance. That should be also valid. Then I will create this view listener by inserting inside the public subject. And then in my view, I will set the onQuery text listener with this particular listener that I created. Then in my delegate, I have the presenter, the source tweet presenter, and I will prepare the view delegate listener with this one. If I want to do that with the flow, then what I will have is channel flow builder. The special thing over here is that I am defining the listener as previously did in RxJava, but the main difference is I have, as you can see here, channel. But channel, if you can see, I didn't create it myself. It's not anywhere here. Why is that? Because channel flow builder is precisely creating this object for us into this particular block. So this is going to be ready for us. Also, as added sugar, we also have await clause. This await clause is another block inside channel flow that's going to be launched every time that we are canceling the scope. That means that if we put here things that we need to nullify, like the view set on query text listener, because we don't want to have memory leaks again, this is perfectly fine here. This is going to be super helpful. But then if we need to do the same with RxJava, the difference is we need to do this manually. We need to cancel this and invoking this cancel, and then making sure that we are canceling this when we are invoking that. We need to make sure that the disposable is disposed as well, and then canceling the presenter just to avoid memory leaks for the clean architecture side. From here, all the same. And now, what do we have here in the search view listener? So I pass the public subject, that's all we know. I make into this listener search view on query text listener. I don't do anything in on query text submit, but I do in on query text change, because anytime I'm typing as a user, I want to pass the query, and then I use the public subject on next, because we need to pass this anytime we do a particular type. And that's the hot stream we have here. If we need to do the same with channels, what I pass here is the same channel, which is coming from the block I mentioned earlier. So this creates for us this same channel, ready to be used. And the same channel have actually this operator, which is called offer. Offer is a synchronous operator, which works perfectly for this particular case we want, because it's working with the UI. We need blocking threading. And then, if we do the same with RxJava, we want to observe that with the subject, then we need to observe with the UI, subscribing into the computation, and then we're gonna have the bonds, because we want to stop those types that the user can do very, very quickly. We'll make sure that the object is different. So that means that the query is not the same that we had earlier, to don't have the same query twice. And then filtering, because maybe you don't want to start when you do an ad, or you do a hashtag or something like that, when you have the first character. So you can do this filtering here. Then in the subscribe, you can search for this particular tweet. You execute actually the presenter. And then if you have any problems, you will show the show problem happen right there into your view. That works. If you want to do the same with the channels, in this case, use the bonds, so same operator, that this did nothing change, same operator again, the filtering, same. all those upstream, so flow on gonna be there to affect those and using the filtering and the distinct and the bounds in the computation dispatcher. Otherwise, you couldn't use the bounds, obviously. Then for on each, it's exactly the same than before. So we use on each, we search the tweet for every iteration in the hot stream, and then we'll catch those things and we'll solve this problem in the presentation if we need to. This is gonna be in the scope that we defined previously, and then we can cancel that when we need it. Cool, so far so good, but are we done with anything we need to get rid from RxJava? Actually, no, we need to do a bit more. For instance, we need to migrate the task training as well. This is gonna be quick, luckily for us. We just need to remove all of those things because we don't need them anymore. We can use the native ones. We can just clean up the schedulers because we don't have RxJava anymore. So we can just keep those new native coroutine dispatchers and expose them in the methods that we have previously, but with the native coroutine context ones being expected. Very cool. So now, synchronous communication design. We are almost ready to finish here. So we want to migrate everything to return, instead of callbacks, StateFlow. And for that, search tweet use case won't have callbacks anymore. So we can remove this contract. We can use a new one with use case StateFlow. We'll remove the different callbacks because we don't need them anymore. We'll expose StateFlow with get StateFlow to the different stakeholders. I use tweets UI state with a nullable object, which that later is a seal class, but you will see that in a moment. StateFlow, the good thing is you can pass them across different files, both hybrid projects with Java and Kotlin. That's super cool. And then I'll pass this from the use case to different stakeholders. I will initialize that in the use case by means of a mutable StateFlow. And then I will expose StateFlow because I want this to be read-only to avoid side effects. StateFlow uses seasonality change by default. That's very cool because then you don't need to do it yourself. And if you do it, you will see in the documentation that you cannot affect StateFlow with this seasonality change because it's there by default. So actually, won't affect at all this StateFlow. Now, the seal class that I had created is tweets UI state. The contract and the different states that I find are, for instance, a list results UI state, returning the different tweets that I have, or when I have an error, a data class having the error UI state with a message, or an object of the empty UI state because I don't want to show any results, nothing happened. And then loading for the pop-up that I show to the user every time I'm starting a new query. And that should be all I need. So I can remove the different callbacks right there. I'm gonna initialize my StateFlow with the mutable StateFlow that we know we started previously with the value. That's the setter for the StateFlow. And I will define first the loading UI state. Later on, I will pass the repository, and then I will make sure that if it's empty, I will pass this to the StateFlow with the empty UI state. Or if we have any results, we'll pass those tweets with the list results UI state. Or if we have any problem, we can catch those up and then passing the error UI state with the message. That should be all we need from here in the use case. Now we go to the state handler, almost the last bit of it. We'll change those things and we'll make sure that the StateFlow handler gonna collect our results. So we are almost finishing. Search tweet resenta contains the use case in the contract that's in Java and the cancellation of the use case here as well. Cool, so we have the search tweets method with the query being passed. We don't need any more those callbacks that a bit annoying are very verbose. So we can remove them from everywhere and we can just expose the StateFlow that we're gonna pass to different stakeholders. So I'm gonna expose that from the use case and to the presenter and to the presenter to some shareholders. So actually the delegate gonna get that from the presenter. Very cool, we have this exposed right here. And then I'm going to initialize this to process the query. So I will make sure to initialize the search view, which is the component from Android, and then the tweets list UI, which is basically something like a fragment or a custom view. So this is up to you. That's why I make this very generalized. So I start that and initialize StateFlow to get this StateFlow that you can see the get StateFlow method. So I'll pass that from the presenter to my view, and then I initialize this StateFlow. And what is going on there? So into my view, I have inside injected the search view delegate and a StateFlow handler And then I will initialize this. This is Java, you can see here. I'm going to initialize the StateFlow. I my view. I will pass the reference of the view, and then I will process the StateFlow collection. So what is inside the StateFlow handler is basically the my view that I initialize with this init method. My StateFlow is going to be late init initialize for later. And yeah, I pass it with UI state, so everything is initialized right now. And now I am starting to collect it. The StateFlow is here. I'm gonna filter because I know there are some null values that can be passed through. Ideally, you wouldn't have any nullable values, but I made that for making that quickly and show you that it can be very quickly done. And then I can actually do on each for any of those states. I will pass the StateFlow and I will handle those states from my view. So I will obviously make sure that I am having this into scope, otherwise you cannot be collecting that. And then what I have in my view, this is an standard function for my handle states, passing those state flows and making sure that the different ones are actually a loading state. Then I show the loading. If it's a list of results, then I show the results. If I have empty UI state, I will show the empty state, or error UI state, I will show the error, or you can put as a default anything you want. I put in this case, show empty state. So cool, now I'm gonna start the cancellation of the coordinate scope. We do it right here. This is gonna be invoked from my view, obviously, and then the string method is gonna start canceling this for the StateFlow handler and also for the view delegate, and then doing this cascade effect to do the cancellation, and then the sort of concurrency will happen. So perfect. So far, so good. Full reactive app done with flow done everywhere, including StateFlow. Nice. So lessons learned very quickly before we go to the questions. Extensible. What does it mean? Because we have different things with this library, we can make sure that we pass different observables, and those observables are what we are expecting from the different layers. You can do it in opposite order, but this helps us to do this iteratively and making sure that we are not disrupting any other teams if you have different teams working in different features. So we can make sure that the contracts are well expected and well defined. Then static concurrency is super cool. We can make sure that we don't have any memory leaks by having this static concurrency. But when we are trying to migrate and we have observables in one side and dispatches in one other side, if you need to return observables, this should be handled as observables. That means that the static concurrency here is not taking any effect, because until you don't have all this area with static concurrency, you won't be able to do that. It's a side effect of having migrations. Imperative and declarative. It doesn't work. Why? It works. Why? When we are working and trying to learn how coroutines work, and you do suspend function, this is imperative code. It's sequential, right? It's very easy to read. But at the same time, when you work with RxJava, you are expecting to do this in a declarative way. So it's a bit mind-blowing when you start doing something like that. So it was for me, but I learned my lesson. RxJava, declarative. Coroutines and flow. Coroutines is imperative code generally because when we use, let's say, suspend functions, we write in a sequential order, and then with flow we put the flow builder, and then again is imperative code. But then when we are collecting things, we use actually a declarative code. So it's a bit like we need to have a few things in mind when we are developing. But then about lifecycle, RxJava is initially manually. You have to dispose one by one, unless you have a library that does it for you. There are a few ones in the open source market. And then coroutines and flow. Static concurrency is super cool, and it can do that for you without any trouble. Then for hybrid projects, RxJava works for Java and Kotlin projects that are hybrid. And if you have any problems, then you can just maybe Rx Kotlin if you have some wildcards that cannot be defined. And then for coroutines and flow, it's perfect for Kotlin and friends. If you don't have any Java, you can just go ahead and use coroutines and flow. Next steps, very quickly. Wait for stable APIs. That means we don't want to have deprecated. But right now, because StateFlow and StateFlow are actually stable and also flow, I think it's a very good moment to migrate if you didn't already. It should be fine to work with them. Just a few things that are not being still stabilized, but it's gonna be soon, I expect. If you have any questions, don't worry, you will have this in the slides later on. You will have the links here to different articles I wrote in the past, and you will have more details into this presentation, so you can read more. Thank you to Manuel Vivo to review those slides for the first and the second iteration, which is this one. Thank you for attending today. And if you have any questions, I am happy to answer if we have any time left. So far, I don't see any questions, but if you have any, I will be happy to answer you. Okay, first question. Should we replace live data with StateFlow? So in my opinion, you can do that. It's ready to be used, and actually you see the different threads that we have in Kotlin Lang and different things. People from Android are recommending to use that and to change it. The thing is, with live data, you have some pre-established things that you don't have with StateFlow, and you will have to do them manually if you want it. So it's really up to you to decide if it's good for your use case and it will work nicely with that. So yeah, I will do that, but take into account that you, with the StateFlow, you don't actually have the power of making sure that it started or it didn't start it, as you will have with live data. You will have to do it manually. You will have to check if you are in on a start or you are in on a stop, because in the background, StateFlow works, because it's meant to be used multi-platform, not only for Android in this case. Okay, next question. For long chains of Rx operations, example flat maps, how can we shorten that? Okay, because you saw probably my example of flat maps. Yeah, by using actually suspend functions, you don't need to use flat maps, because you can use suspend functions and returning things from one side to one another. So you wouldn't need to use flat maps in that case, flat map concat actually. But if you need something differently, depends if you use different flows, then you will need to use actually flat maps, and that's cannot be avoided unless are actually suspend functions, which means it's one set of operations combined. Okay, next question. Can we get GitHub for code? Yes, as I mentioned, it's not GitHub actually repo, but it's gists. That means that my user of GitHub also works. So you go to my gists with my user of GitHub, you will see the different code snippets that I have there, including some unit tests for the handler and also for the use case. So you will see that there. Okay, next question. Moving everything to Kotlin Flow can also prepare for Kotlin multi-platform. What is your opinion on that? Yes, I didn't work myself with Kotlin multi-platform, but I totally agree that if you use Kotlin Flow and suspend functions, so you can get your project ready for Kotlin multi-platform. As I mentioned earlier, StateFlow is, for instance, ready for any kind of platform. It doesn't really rely on different states of a life cycle of an Android application. That means that you can reuse that for Kotlin multi-platform perfectly. And you can make sure that you need something in when it's unstarted, and you need to stop it when it's unstopped. You have to do it yourself, but that's something you have to deal with it. And obviously, it will be ready for Kotlin multi-platform, yes. Also using Servflow. Cool. I don't know if we have any more questions. Can wait one more minute if there are more. And later on, I will say bye to you if there are no more. Okay, I don't see more questions so far, so I think thank you for. Oh, okay, one more question. How can multiple click on single UI item can be handled like enable, disable with RxJava? So, okay, you mean, yeah, there is this kind of, yeah, that relies on RxJava with this library that is using for the click. If you want to do the same with flows, I suppose you have to dig into that a bit further, because I didn't do that myself with flows, but in a similar way. If it was with RxJava, I would work with flow, that's for sure. So you want to have a kind of relay, you will have to dig deeper and try to do yourself some helpers to make that available. But I'm pretty sure that it can be working for sure. With an event bash, it will work for sure as well. So maybe with StateFlows, it can be a way to do that. And with StateFlows as well. So by doing that, you can make sure that you are handling those clicks and changing them accordingly. So that should be it. Yeah. Okay, I don't see more questions. Thank you so much. Thank you for attending today. Hope you learned something, and also glad to share my things and my thoughts. Thank you to droidCon APAC for inviting me today, and see you soon.